Assalamu alaikum. Myself Mariam Ali. Today I am going to explain you about the turtle blind follower report here. So basically in this I am going to explain you about the block diagram, some of the functions of IR sensor and by using the PWM and the serial port. And further on I am going to explain you how I wrote this code of three IR sensors. So basically my logic is that when as it has three sensors, so I get 8 combinations here. At 000 and at 010, my robot is going to move forward. But at the if left two sensor is on or the extreme left is on, then my robot is going to move left. And similarly, if my extreme right or extreme two right sensor are on, then I'm going to move right. So basically these this state table is the combination of how I draw this state diagram here. So the starting point of my robot is that it starts from 000. So when it is from 000, then it's going to get start and move forward. Now there is a point here when it gets 001. Then it's going to move here right. But at that right point, when it gets, for example, 100, then it have to move firstly to the 1 and then it go for from 1 to 4. So this is how I wrote the state table here, that at 000 I'm going to move forward, but similarly if I am at 101 at the stop position and I have to move onward, then I'm going to stop here. Similarly, if I am at this position, there the motor is moving right, but my condition is that I have to move left. So the first motor goes to the condition 1 has stopped and then it goes to the that it have to move left. So this is the code here. So basically in this code is written on the Arduino IDE, and in this there are predefined libraries, so I don't have to load further things here. So there are two functions, setup and the loop here. So for the setup, I define the pins of left sensor, middle sensor, and the right sensor. And the further on for the left motor and the right motor. For the left motor, there are two ports, as the motor have two connections, positive or negative. So whichever condition we apply, so according to that, I am going to set the clockwise and anti-clockwise directions. Further on, according to my logic, I apply the if else condition here and I apply the forward, left turn, right turn and the stop. And the three sensor here, that is A, B and C, I define it here. And further I assign the pins that which have to be high and which have to be low according to this state table, sorry. So this is basically my whole turtle board is working. Basically the whole function is that a turtle board is following a line, a black line here. Whenever it gets on the black line, it turns off, and on the white area, the sensor turns on, and according to that, it moves on. Further, I have one more thing to explain you, and that is this HEX keypad calculator. So basically, in this HEX keypad calculator, there are two ways. First, the way is that I have to use a 328P AVR chip, and with that I have to use a IC MM74C to interface the keypad. But I used here is 2560 mega, 8 mega 2560, and I don't use this IC to interface my keypad. From my code I interface the keypad. So basically this is the code here. This code here. The code is that the code is simply as according, I'm going to explain you logic here. The logic is that this is a keypad here. So basically, these are the four input pins and these are the four output pins. These are the self-assigned for my interfacing of a keypad. I self-assigned it to that it goes in a infinite loop that 0 1 0 0 0 0 1 0 0 that once it high then this then this then this, and according to that this byte here, and I define this resistor here so that some value stored here and save it to the some variable in my code. So this is the code here. I assign values here and then these three arrays are the values which converts my value to print it on the LCD print screen. So what I am telling you is that I have assigned port D to 0x1, 0x2, 0x4 and 0x8. So it works like that whenever I'm going to click the 0 as it going movement 0x1, 0x2 onward up to so on. When I'm going to click here 1, then this is on and this is on and it's going to get 1. Similarly, if I'm going to click this 4 for 4, then this have to be on and it is automatically on as it is going in infinite fashion. And the further thing is that in our keypad, I have assigned this on C to reset my calculator, and further these are the functions here, and in these functions I in my code I applied that in these functions whenever I click this, it is for the LCD here to print it on the LCD. But further, I save a press1 variable that for the press1 specify that it have to perform division. And similarly, for the 2, 3 and 4, it have to perform multiplication, subtraction or addition. And further, whenever I click this that I have to multiply, subtract or divide, then it's going to get to the value B that I am going to provide now the second value. So it goes in this loop here, value B. And this value B, similarly, all the functions again perform as I performed before for the first variable. But the only thing is that when I'm going to click this equal here, when I'm going to click this equal here, then the thing is like that it's going to perform at press 1, which I previously stored at. For the press 1 I have to perform the division. So similarly this perform a value is stored at the F and then it converts it to the string to display it on the LCD. So this is the code here. For example, I'm going to multiply 1 multiplied by 6 equal to 6. Similarly, if I have to do 9 plus 8, then it has to be 17. Similarly, if I am going to provide the here 5 cross 5, then I'm going to show as 25. So basically, I have not used the IC of I use simply the interfacing like that. I am providing this 4 as the output, and by using this, I am controlling this keypad. And further on, for the interfacing of that keypad store or give value in the hex form. So I apply this condition here, this thing. So it converts the hex value to a decimal one and it prints here. So this is all for today. Thank you.